So, lesson 3 in number sense 1, we're doing rational numbers. So, when we think of rational numbers, a lot of times what we're looking at is it's basically something that can be expressed as a fraction, right? So, think fractions, okay? But we call these rational numbers. When we have a number that can be written in the form a over b, where b is not equal to 0, it is said to be a rational number, okay? See, aka a fraction. It's important to note that we refer to a as the numerator, so that's the top, and b is the denominator. So you're going to hear me say numerator and denominator a lot. And so if I'm talking about the numerator, I'm talking about the top. And if I say denominator, I'm talking at the bottom. Now, when we look at these, we can say that a, which is the top, the numerator, and this says how many. So how many parts do we have? And we have it over b, which is the denominator. And that's talking about what size the parts are. Okay. So B really talks about the size of the parts, where A talks about how many we have. Okay. Now we have different types of fractions that we can talk about. We have our proper fraction, which would be written there. Now in a proper fraction, the numerator is smaller than the denominator, right? And it's reduced to lowest term. So what that means is that I can't divide anything out of both the top and the bottom. So here I have 3 over 4. I can also write this as negative 3 over 4, which is what I would prefer, because the top talks about how many, we would rather have that negative sign in the top, okay? We also can have something called an improper fraction. Now, what's improper about this, oops, I don't want that pen, is that the top is greater than the bottom. So if we see here with this improper fraction, the numerator is larger than the denominator. Okay, and that's considered improper because I can reduce it to what's called a mixed fraction. And again, I'm using the wrong pen. Sorry about that. So a mixed fraction consists of what we have is we have a whole number and a part number, which is the fraction part, okay? So let's take a look at what this might look like if we're thinking about a whole. For the negative 3/4, that means that this is cut into 4 pieces. And I'm going to make it a little more even. I can actually use my ruler for that. Oops. Well, that didn't help me at all. Hopefully I'll do better in class. Okay, so I have a circle. It's cut into 4 pieces. Now this says I have negative 3 of them. So basically what I'm saying is that 3 are shaded in. I wonder where I am recording this. Okay, so we have that. And in this case, we would say that this would be like a negative, 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 right? Just because it's a negative 3/4. When I have the improper fraction, so I have my circle, I still have it in fourths, right? So these are still cut into 4 pieces. So, but in this, I now have to shade in 7 of these pieces. So I'm shading in here. I can shade in a whole, there's 4 of them. And I have another 3, right? Because the total number of pieces shaded in are 3. Okay. Now here I have my mixed fraction. In my mixed fraction, I only have one of these that is actually cut into fraction, right? Because the other are wholes. So I only have to split up the 1. And now this is 3 1/2. So when I'm shading these in, I have this whole, this whole, this whole, and this half. So 3 1/2. Okay. Now let's break these down so we understand what the pieces are. If I'm looking at my proper fraction, my numerator is -3, my denominator is 4, and my definition of what a proper fraction is when the numerator is smaller than the denominator. Okay. Now if I look at my improper fraction, well, my numerator here is 7, my denominator is 4, and my definition here is when, what am I writing? When the numerator, that's the top, is larger than the denominator, which is the bottom. Okay? Now, when I have a mixed fraction, my numerator, oh my goodness, we just got a musical interlude here because I'm recording this in the school, and this is telling kids it's time to get to class. So please bear with me with my background music. So the numerator in this case is 1. My denominator is 2, but I also have that 3. So the definition of a mixed fraction is we have a whole number and sorry, I'm distracted by the music, and a fraction. So we're greater than 1. Okay? Alrighty. Now, we're going to do some practice converting some fractions. So, when we're converting fractions, we have, if we have here, we've got 25/3. Now, I've got kind of it broken down here in terms of long division, how you would kind of break that in. We've got our quotient and our divisor, remainder. But the basic thing you need to do is you need to say, okay, how many times does 3 go into 25? So we're going to go 25 divided by 3. And when we do that, 25 divided by 3, we're going to get what did I do? 25 divided by 3. It goes in 8 times, and it's 8.3 repeating. Okay? I'm sorry, guys. There we go. Hopefully that's done now, right? Now, when it goes in 8 times with 3 left over, then what we can say to ourselves is we can go, okay, well, 8 times 3 is equal to 24. So if I look at this, I have used up 24 of those 25s, right? So how many do I have left over? I have 1 left over. So I can rewrite this as 8 1/3. And here we're going from improper to mixed, right? So basically, if you divide the top by the bottom, whatever you have at the decimal, that's going to tell you what's left over. But what you do is you take that front term, the 8, and you multiply it by the denominator, the 3, to find out how many of the ones in the top you've used up for your whole numbers. And I mean, you can sketch them all out. There's a lot of different ways to kind of figure it out, but that's a lot of work. So it's easier to just kind of do this kind of conversion. So steps: divide the numerator by the denominator, the remainder, and that's what's left over. This one would be our remainder, right? So the remainder will be the new numerator. The quotient will be the number in front of the fraction. So basically, when we divided 25 by 3, we got a quotient of 8, and that's the number in front of the fraction. So 8 is your quotient, right? We got it from there. The denominator always stays the same. We're going to do some more practice with these. Now, here we're going the other way. Here we're going mixed to improper. And this is actually easier. All you have to do is multiply the 4 times the 3 and add it to the 2. So we keep the denominator the same. We're going to go 4 times 3 and add it to the 2. So when we do that, we get 14 over 3. 4 times 3 is 12, plus 2 is 14. Okay, so you multiply the denominator by the number in front of the fraction. If it's negative, ignore the negative. You're going to add the negative at the end. Add that number with the numerator, and your result will be your new numerator. Denominator stays the same. Okay, now, hopefully that makes sense. We're going to, like I said, we're going to do some more practice. Practice makes perfect. Cannot convert improper fractions to, sorry. Cannot convert proper fractions to improper, vice versa. Oh, if something's a proper fraction, you can't make it an improper fraction because it's an already proper. Okay, I don't know why that's there. Equivalent fractions. Now, equivalent fractions are fractions that are equivalent, equal, when they reduce, divide the numerator and the denominator by the same number to the same form. It's the best to reduce answers to simplest form. Always try to reduce fractions before applying any operations. It'll make it easier. So when we're talking equivalent fractions, sometimes we want to put things in what we call lowest terms or simplest form. So, for example, if we have 50 over 100, well, I can divide the top and the bottom by 10. As long as I do the same thing to both the top and the bottom, it's equal. And when I do that, I get 5 over 10. Well, when I have 5 over 10, I can divide the top and the bottom by 5. And again, as long as I'm doing the same to the top and to the bottom, I'm not changing its value. When I do that, I get 1/2. We would say that these are all representations of 1/2. Now, 1/2 is what we call simplest terms. because I can't reduce it any further. That is what we prefer. So this is preferred. It will make your work easier, and it also is cleaner. So let's do some examples with these. We're going to reduce the following fractions if possible. So if I have 12 over 52, I know, because I know cards, that both the top and the bottom can be divided by 4. So 12 divided by 4 is 3, and 52 divided by 4 is 13. Now, that would be my lowest terms. There's no number that I can divide 3 and 13 by, so this would be my lowest terms. Okay? 16 over 24. Well, I can divide the top by 8 and the bottom by 8. And that would give me 2/3. Now, 2/3 is in lowest terms because 2 and 3 have no common factors. You gotta remember all your lowest common factors. I don't know if you guys remember that. Maybe we'll do some reinforcements with that. Negative 42 and 49. Well, these are both divisible by 7. So when I do that, I get negative 6 over 7. Remember, okay? Once we can't divide them anymore, you are reduced to simplest forms, okay? So we want to reduce them. So that's what reducing means. Reducing to simplest forms means dividing the top and the bottom by the same number till you can't do it anymore. 24 and 28, I can divide both of these by 4, and I get 6 over 7, lowest terms. I can't divide 6 and 7 by anything that's the same. 50 and 75, I can divide both the top and the bottom by 25, and I get 2 out of 3. Okay. 8 and 6, well, I can divide this by 2, and I can divide this by 2, and I get 4 out of 3. Now, here's the thing. We would consider simplest terms, we would this is an improper fraction. So I would actually reduce that. I would divide the top by 3, and I'd get 1, and I'd have 1 left over. So I would change that one to a mixed fraction. Okay? Depending on what you're going to do with that fraction, you might leave it improper if you had more work to do with it, but the more complete answer is to reduce it to 1 1/3. Now, it says, determine whether the following are equivalent fractions. So, basically we have to say, did we do the same thing to the top and to the bottom? So here, to get from 5 to 1, I divided by 5. To get from 55 to 12, well, if I divide by 5, I get 11. So no, this is not equivalent. Okay? Here, to get from 16 to 64, so let's just see, 64 divided by 16 is 4. So I times by 4. When I times 48 by 4, I get 192. So I did the same to both, so yes, this one is equivalent fraction, okay? Convert the following from mixed to improper or vice versa. So if it's improper, we're gonna go to proper or mixed, sorry. And if it is mixed, we're gonna change it to improper. So 17 over 5, well, that is clearly improper. So we divide 17 by 5. And I get 3.4. So I know it's going to be 3. Now 5 times 3 is 15. So 17 minus 15, I have 2 left over. Okay? Let's do the next one. Negative 23 over 7. So just go 23 divided by 7. And I get 3.28. So 3 times 7 is 21. So that means I'm going to have 3 here, and 23 minus 21 is 2, but don't forget that negative sign. So just put the negative sign in afterwards, okay? The negative would go in front of the whole number, okay? 2 and 1/8, these are easier. Multiply 2 times 8 and then add 1, so 2 times 8 is 16 plus 1 over 8, so 17 over 8. Okay. Similar here. 5 times 3, so 5 times 3 plus 2 all over 3, 17 over 3. Alrighty. Negative 4 times 2. Okay, now here. This is tricky. So when we're going to put a negative number here, we're going to put everything in brackets. So 4 times 2, and then plus the 1 over 2. So the whole thing becomes negative. So 8 plus 1 is 9 over 2. Okay, so watch out with negative signs. So 99 divided by 5 equals 19.8. So 19 times 5 is 95. So why did I do that? So that means you have 4 left over. So negative 19, and 99 minus 95 is 4. Okay, so that would be our mixed number there. Now, adding and subtracting fractions, much fun. So lots of instructions here. Hopefully this is something we remember how to do, but if not, we're going to review it. Fractions, in order to add them, remember when we talked about the denominator and the numerator? The denominator tells you what size the pieces are. So in order to add or subtract fractions, you have to be talking about the same size pieces. So fractions have to have the same denominator in order to add or subtract. It's easier to add and subtract with mixed fractions when they're written in improper format. So be sure to do the conversion if necessary. Okay? Now, steps. Like fractions are fractions with the same denominator. You can add and subtract like fractions easily. Simply add or subtract the numerator and write the sum over the common denominator. You do not, do not add or subtract the denominator. So once you have that denominator, keep it. And then make sure that your final answer is in simplest or reduced terms. But if those fractions have different denominators, you have to find equivalent fractions with the same denominator first. And this is how you do it. You find the lowest common multiple of both denominators both numbers in the denominator. Rewrite the fractions as equivalent fractions with the lowest common multiple as the denominator. Once the fractions are like fractions, you can add or subtract the numerators and write the sum over the common denominator. Do not add or subtract. Do not add or subtract the denominators. And then, of course, make sure that your final answer is in simplest or reduced terms. So what does that mean? Okay, let's take a look. Well, here we have like fractions. They're like because the denominators are the same. So this one's easy. All we have to do, we keep that denominator, and it's 5 plus 3. So 5 plus 3 is 8 over 6. Now we want to put that in mixed form. So first we're going to reduce it, right? 8 can be divided by 2, as can 6. So it'll be 4 over 3. 3 goes into 4 once, and there's 1 left over, right? So it's 1 1/3. Okay. let's look at this next one. Now, these are unlike. My lowest common multiple of those denominators is 10. That's the lowest number that both 5 and 2 can go into. So I'm going to change each to equivalent fractions over 10. So 2/5 over 10 would be, well, what did I multiply it by? I multiplied 5 by 2. So 2 times 2 is 4. 1/2, I multiplied 2 by 5, so I multiply 1 by 5. Okay, now I can do my subtraction. So 4 minus 5 is -1 over 10. Okay, and it's already in lowest terms, so I cannot reduce it any further. Okay, here we have another example of unlike. So our lowest common multiple of 5 and 6 is 30. Okay, so equivalent fractions, I'm going to put them both over 30. I multiplied 5 by 6, so I have to multiply 2 by 6. 2 times 6 is 12. I multiplied 6 by 5, so I multiply 1 by 5, and I get 5. Now I have like fractions, so I can add them over 30. 12 plus 5 is 17. There is no common factor for 12 or for 17 and 30, so that is my final answer. So you can see how we're using our equivalent fraction skills as well as our common denominators in order to add these. Okay, let's do another one here. How about you guys pause your video, try the next 3, and then come back and see how you did. Okay, so we're back, all right? So lowest common multiple of 9 and 10 is 90. So 90 plus 90. So first, I multiplied this one by 10. So 5 times 10 is 50. Here, I multiplied 10 by 9. So 7 times 9. 7 times 9 is, I have to think about that one, 63. You can use your calculator too. Okay, so 50 plus 63 is 113. Now I have an improper fraction, so 113 divided by 90, it goes in once, and there are 23 left over. Okay, next one. How do we do on this one? So our lowest common multiple of 8 and 2 is 8. So that means for the first one, it didn't change. So I can just write 5 over 8. The only one that changed was the 2. I multiplied it by 4. So I multiply the top by 4, right? So this equals 4 plus 5 is 9 over 8. It's an improper fraction. 8 goes into 9 once with 1 left over. So 1 and 1/8. All right, so here, lowest common multiple of 8 and 7 is 56. A lot of times to find your lowest common multiple, you just have to multiply the two numbers. So 8 times 7 is 56. So that's how I get that. So if you're saying, how do you get that, miss? That's what happens. So 8 times 7 was 56, so 1 times 7 is 7. And here, 7 times 8, so 1 times 8 is 8. And then when I do that subtraction, 7 minus 8, we know from our integers, is -1 over 56. And I can't reduce that any further, so I'm done. You'll notice a lot of times I like to put a little box around my final answer. I always like to think that you're giving a present to your teacher, right? So put it in a box. Now, when we have mixed numbers, what we're going to do is we're going to convert them to improper first. So convert mixed to improper first. Okay, so to do that, 1 times 4 is 4 plus 1 is 5. So this is 5 over 4 plus 2 times 5 is 10 plus 2 is 12. Okay, now my lowest common denominator of 4 and 5 is 20. So here we go, 4 times 5. So we're going to go 5 times 5, which is 25. Hopefully you can follow my color-coded lines. 5 times 4, so 12 times 4 is 48. Okay, I add those together and I get 70, oops, not 72. Where did that come from? I get 73 over 20. Now 20, so 73 divided by 20 equals 3.65. So I know I'm going to have a 3 here. So 20 times 3 is 60. So I have 73 minus 60, 13 left over. So 3 and 13 over 20. Okay. Here we go. So hopefully that makes sense. I like it to put your answer in mixed because technically that's more complete. Now be careful of these negative signs. Okay, so we're going to convert first. So 2 times 7 is 14 plus 3, 17. So that's negative 17 plus 1 times 5 is 5 plus 2 is 7. And if you've noticed, I'm going to do that. I change it to plus a minus instead of a, just because that's going to make things easier. So now let's rewrite that because you can follow my pattern better. So lowest common multiple of 7 and 5 is 35. So here I multiplied by 5. So minus 17 times 5 is minus 85. And here I multiplied by 7. So negative 7 times 7 is negative 49. Now they're both negative, so I'm just collecting negatives. So 85 plus 49 is 134. So it'll be 134 over 35. And I want to convert that. 134 divided by 35. .82. So I know my number here will be 3. I still have a 35 here. 35 times 3 equals 105. So it'll be 134 minus 105. So it'll be 29. And don't forget our negative sign. Okay? So that would be our answer. Okay. Let's do another one. One more example. If you want to try that one first. And then come back and see how you do. Okay, so first thing I'm going to do is I'm going to convert this 1 2/3. Oops, that's a plus sign. Plus, so it's over 3. 1 times 3 is 3 plus 2 is 5. So 24 over 7 plus 5 over 3. Now, my lowest common denominator for 7 and 3 is 21. And then I'm going to multiply 7 times 3. So multiply 24 times 3 is 72. And then 3 times 7. So 5 times 7 is, 35. Now I can add my denominator, or my numerators. 72 plus 35 is 107 over 21. To convert to mixed form, .095. Okay, so this will be 5, and then 21 times 5 equals 105. So I just have 2 left up top. Okay. All right, so we did a lot of different skills there, adding and subtracting fractions, finding common denominators, finding equivalent fractions, converting from mixed to improper and back. It should feel like a bit of a review. You're going to start by reducing fractions to simplest terms and then moving to adding and subtracting. I know fractions aren't people's favorites, but hopefully a little bit of practice will get us good at them.